Right. Today we're going to be looking at differentiating functions whereby you don't have y, instead you have something like s, and whereby you don't have x, instead you have something like t. So here we have the variables y and x. However, here we have the variable s and t. Now, s could stand for something like distance, and t could stand for something like time, for example. Now, remember that if you divide distance by time, right, or if you get the difference in distance divided by the difference in time that a car takes to travel the distance, then you're actually working out speed. So what's happening here, if I call this s the distance, this s here, and I find the change in that s, the distance, and I find the change in time, what I'm actually doing here, by differentiating that, I'm actually working out the speed without noticing. So later on, we're going to look at the application of differentiation. So if I want to see the rate at which a car is increasing its distance, basically I'm trying to work out what speed is. So I'm trying to see the change in distance divided by the change in time. That's going to give you the speed. But we're going to go back to that later. We're going to come back to that later. At the moment, I just want to show you how you can do this. Okay. Now, here, we're going to do the very same thing. However, instead of getting dy dx, we're going to use ds. S is the y now. Dt. Okay. I'm find the difference, the rate of change of s with time. There is the rate of change of s with t. Now, you're going to do the very same thing. This 5 here, which is a power, you're going to times it by 4. So that's going to be 20. And then now that t, what's going to happen? The power of which is 5 is going to go down by 1, so that's going to become 4. Now remember there's 5 at the bottom, which you can just basically put in front of the under 20 here. Okay. As for this one, it's going to be 3 times by 1, which is going to be 3, and then t to the power of 2, all over 6. You can just basically put that 6 to be under 3 here. It just becomes easy to simplify. Now 20 and 5. 5 goes into 24 times if I simplify, and 3 goes into 6 twice. So here I've got 3 goes into 3 once, and 3 goes into 6 twice. So basically I've got 1/2, and then with t squared at the bottom. Now another way you can write this, you can let this to just basically be t squared over 2. It's like you are just halving the t squared. So t squared over 2 is the same as a half of t squared. It's the same way of writing it. Okay. So they could ask an exam to differentiate or to find what we call derivative. Derivative basically means is what we call the differential, is what you get when you do ds dt or dy dx. So the answers we've been getting here, we call them derivatives. Okay. Right. So now what I want you to do now, I'd like you to pause the video and try question 4, A, B, and C. Now remember for question 4, A now becomes y if you want, and B now becomes x. So you're going to be doing dA dB. Okay, so dA over dB. So have a go at that please quickly. Okay, hope you've tried them. So I'm just going to show you the answers. If you want to pause the video and use these answers to mark your question, please. So question 4A, there you are, question B, and question C. Okay, hope you've done well on that. Now moving over to the next questions, I would like you to try question D, E, and F, please. Okay, well done for that. Hope you've tried that. I'm going to do question F for you, so then you just maybe become confident in that. So I've got M here. Now, when I have everything, let's say for example I've got 3 over 5, and I'm adding, say for example 1 over 5. This is going to be the same as 4 over 5. You don't have the bottom number, but this 4, you see I can write it as 3 plus 1 all over 5. Okay. So if I have 3 plus 1 all over 5, what I could do is to basically split them up separately. So this is going to be 3/5, and that's going to be 1/5 separately with a plus in between. So that's a concept you're going to be doing here. So I'm going to have the 4, which is going to be the denominator, comparing it to the 5 and the 5. So I'm going to have n to the power 4 over 4 separately. So n to the power 4 over 4 separately, minus 2 n cubed over 4 separately plus n squared over 4 separately. So then it becomes very easy to differentiate this. So when you have everything all over one thing, you can always split them up. Now at this level now you can differentiate. To differentiate, we are trying to find dm, dn. M is y and n is going to be x. Starting with that, I've got 4 times by 1, which is going to be 4, n to the power of 3. Remember there is 4 at the bottom, so you can put all over 4. And then I've got 3 times 2, which is going to be 6, n squared, all over 4. And then I've got 2 times 1, which is going to be 2n, because that goes down by 1, so that's just going to be that, all over 4. And all I now need to do is to simplify. 4 goes into 4 1, so this 4 will cancel out, so I've got n cubed. Right here, I can simplify. 2 goes into 4 twice, and 2 goes into 6 3 times. So I'm going to have 3 at the top, and of course with n squared. With this one, 2 goes into 2 once, so I've only got n at the top, and 2 goes into 4 twice. Okay, so that's going to be your final answer to that question. Okay, now for the rest, if you just want to pause the video now and use the answers to mark your screen. Okay, hope you've done well on that. So moving over now to the next slide, which is going to be that. I've left the answers there for you. So if you just want to pause the video, try the questions and then mark your answers. The same approach as what you've been doing. Okay, right, so hope you did that. I'm just going to go quickly to question X for you. Now with X, what you're going to be doing first is to make sure that you separate everything. So I've got X equals to t cubed all divided by 2t. And then I'm going to have minus 8t squared all divided by 2t. And all you need to do is to simplify this. Remember, this t has got 1 there, and this t has got 1 there. So if you're doing 2t cubed divided by t to the power of 1, you know you take away the powers when you're dividing, right? So that's going to be looking something like this. You're going to end up with t to the power of 2 at the top, while 2 is staying. Now, this 2 at the top has come from 3 take away 1, because if you're dividing, you take away the powers. Then, here I've got t squared divided by t to the power of 1. 2 take away 1 is basically t to the power of 1. So that's going to be 8 t to the power of 1 over 2, right? So just showing that, so that from there you can then take over from that. So from here, you just do the very same thing. The bottom numbers are the same, right? So what you need to do now is try not to bring them together, differentiate them separately. Okay, and then you should get the answer to that. Well done.